Hello students, our next topic is a sliding bead and what is the Coriolis force acting on that bead. So this is our bead which is sliding without friction on a horizontal rigid wire. So this is the rigid horizontal wire on which the bead is sliding along this direction, and this wire is attached to this bar, and this is moving, or it is rotating at a constant angular speed omega. Initially the bead is at a distance r from this axis of rotation. Okay, now the problem is to find the force exerted on the bead by the wire. So what is the force exerted on the bead by the wire? So we have redrawn that figure. So it is the figure seen from above. So this is our axis, this is the rotational omega angular velocity, and you can see the bead here, and it is moving in this direction due to the centrifugal force F centrifugal, and you can see a Coriolis force acting in the perpendicular direction on the bead, and it is normalized by the normal reaction or the contact force, the normal reaction on the bead. Okay, these are equal and opposite. So in the coordinate system rotating with the wire, the motion is purely radial. So we are considering the rotating coordinate system in which the wire in motion is purely radial. Okay, now this is the force with which this bead is moving or sliding. Okay, and these two forces cancel each other. So this is the radial part and this is the tangential part. So we start writing the equation. So here F cent is the centrifugal force and F core is the Coriolis force. So it is the frictionless wire, we have said earlier. The contact force N is normal to the wire. Always the contact force is perpendicular to the contact surface, and since there is no friction, only normal reaction exists. Okay. Now in the rotating system, the equations of motion are this is the radial equation and this is the tangential equation of force. So F centrifugal is equal to m r double dot. R double dot means it is the acceleration of the bead. It is moving in along this direction due to this force. So F centrifugal is equal to m r double dot. R double dot is the acceleration. This is one of the equation, and next equation is N and F Coriolis. Since there is no perpendicular movement for the bead along the wire, they are equal. Therefore, N minus F Coriolis is equal to 0. Okay. Now, what is the centrifugal force? F centrifugal, you know the equation, that is equal to m omega square r. So, when we substitute the this term F centrifugal in the first equation, you get m r double dot minus m omega square r is equal to 0. So, this equation has a solution for r is equal to a e raised to omega t plus b e raised to minus omega t, where a and b are the constants which depend on the initial condition. Okay. Now the tangential equation of motion expresses that there is no tangential acceleration in the rotating system. Therefore, N is equal to F Coriolis. You know the equation for Coriolis force 2mr dot omega. R dot is found from this equation and substituted here. So you get an extra omega from this derivative. You get 2m omega square a e raised to omega t minus b e raised to minus omega t. So in this case, there is no Coriolis force or there is no tangential acceleration for the system. There is only radial movement for the system, which is expressed by this equation of motion. Okay. Thank you.